In mathematics, we are required to solve equations. Um, it's quite easy if I tell you, right, what is 2 plus 3, and you'll immediately shout and you'll tell me it's 5, and that's correct. If we go back to our lower grades, they've replaced one of those numbers with a square, and they ask you, right, work out the square's value. And you could either count on your fingers or so. Um, but what your brain essentially does is it takes everything that you know. So we don't know what the square is, but I know what this is and I know what this is. And it puts it on one side and leaves your unknown, apologies, your unknown on the other side. We can also then solve equations. So if I leave my square here and I say, right, 2 plus something has to equal 5. So I can say 5 minus 2, and that will give me, therefore, 3. We do the exact same in grade 7, just slightly different. So first things first, we replace our square with either a little x or a y or a letter. This is the introduction to algebra, right? So if I tell you, okay, 2 plus x minus 4 is equal to 20. So let's say plus 2. Right. So what do you know? I know what this 2 means. I know what this 4 means. I know what this means. I know what this means. In other words, this is the one I'm concerned about. In other words, it's your square. So when we solve equations, it's very important you leave your variable or your unknown on one side and all your constants, in other words, all your numbers goes across to the other. So keep your equal sign where it is. Think of it as being a finger that's lying down on your piece of paper with your, I don't know what it's called, like little knuckles or whatever sticking out. Leave that there. So leave your equal signs beneath one another. Right. Leave your unknown where it is. And everything that you do know, move across. Right. So 20 plus 2 can stay there. If you wanted to write 22, that's fine as well. Now, when something goes across the equal sign, it changes its property. So here I wrote minus 4. So if it goes over, the opposite of minus 4 will be plus 4. Again, this is a positive number, so if it had to go across, it had to be a negative number. The left side is now solved. Now I solve my right-hand side. 20 plus 2 is 22, plus 4 is 26, minus 2 is 24. And what's brilliant about this is you can do a little test. And we test as follow. 2 plus 24. So what I'm doing is I'm recopying this line and I'm substituting my answer to test if it equals on both hands. Minus 4 equals 20 plus 2. So if I solve my left and I solve my right, I should get to the same answer. So 2 plus 24 is 26. 26 minus 4 is 22. 20 plus 2 is 22. Once your left-hand side is equal to your right-hand side, then you know that your answer is correct. So another example is, let's say I bring in times. So 3 times x equals 36 plus 2, or rather plus 3. So if we do this, we do the exact same step. Keep what's unknown on one side and move what is known to the opposite. So again, my only issue here is that I first need to bring this as one term. Reason being is that when we work with times or divide, everything that's on the other side first needs to be one number before I can take my times or divide across. So if there's a lot of plusing, a lot of subtracting, first do that. And at your very last step, do we break up the times or divide. So with that being said, 36 plus 3 is 39. 3 times x. Now I can move this across. So the opposite of times is divide. So x would equal to 39 divided by 3, and that will give me 30.